Assalamu alaikum and welcome back to all of you. Today you are going to learn how to plot beautiful sinusoidal functions such as sine wave and cosine wave. You have read in math that sine of x or cos of x is periodic with a period of 2 pi. So today we will learn using the basics which we have already done in the previous lecture. So we use those. So namely the math function or the math library, the list, and one new library that is called the um matplotlib.pyplot, which is used to visualize or plot the figures. So let's start by importing the library. So let's start import. You understand this is the Google Colab. So you have the idea how to write code here. So import math library. Then let's import another library called the uh, matplotlib.pyplot. Import matplotlib. I think I made matplotlib.py plot because name is very long. So let's give it a nickname that is the PLT. So import matplotlib.pyplot as a PLT. And then we use the list, which you have already done. So let's generate two lists, one list for the angles value and one list for the sine values. So I write x equals to square bracket. You understand square bracket means list. Okay, and then I write y equals to square bracket. So that means we have generated two empty list. Then we use the for loop. So for I in range say 0 to 359. Okay, so this is the for generating the angle. Then you understand that we convert these angle into the radians. So I'll write angle equals to math, and to access or to use any function, we use the dot notation. So I write math dot radians. Radians is the function that converts the angle into radians. So I write I here, and then I write another another value that is the sine value. So I write sine, for example, v is equal to math dot sine. Sine is the function inside the math library. So I wrote, because we are going to plot the sine waveform, so I write sine, and then input argument for this is angle. Okay. Then I write x dot append. Dot append is the function for the list which is used to append or include a member to it. Okay, so I write x dot append, and inside parenthesis I write the angle. So what it will do, it will add angle value to this one. Okay, similarly y dot append, again y is list and append is a method or function inside to be performed on the list. So I write append, and then I write sine v. Okay, so what it will do, it will, here we are going to calculate the sine value of this angle, and then this value is then stored, you can say, inside the list. So that's about this one. If you are understanding, write in the comment section, I plotted my first sine wave. Okay, so that's all for this one. Here we have generated the sine wave. Now to see if the sine wave is generated, we will use the matplotlib.pyplot library, which is used to plot the functions, okay, or any graph. So let's use it. So we use PLT, And inside it, we have the function called the plot. So I will use plt dot plot. Now to plot, we need the x values and the y values. Okay, so I write x and comma y. Okay, so that's what you understand. That's so simple. Again, in some environments, this doesn't work. Okay, so we use one additional function that is called plt dot show with empty parenthesis. So let's run it. So you understand this is the run button. I just click it and you will see that it will plot the signal. Uh, Okay, so list object has no attribute apparent, or so you see I've written there's a spelling mistake here. So let's correct it. But remember, don't scare of the mistake. Mistake give you, I mean, you get better learning when you make mistake. You read the mistake and you understand what mistake you have done. So let's rerun it. And this is the sine wave generated. Okay, so the sine wave is from 0 to 359. Okay, so you understand the sine wave and cosine wave are periodic with a period of 2 pi. So 2 pi is basically in radians. So if we write them in degrees, then we say that sine wave and cosine wave are periodic with a period of 360 degree. Okay, so what if I want to scale this one? Okay, so you understand the amplitude of this one is along x-axis. So you see its maximum value is +1, and similarly its minimum value is -1. So what if I want that its maximum value should be, say, 3 and minimum should be -3, so that we normally call it scaling. So let's use the same function. I just Control A and Control C and plot it in the next cell. Okay, and let's write. So anyone can guess how to plot the sine wave with amplitude of, say, +3 and -3. I give you a second to think, and then I'll just write. If you've done it, please write in the comment section that you did it before I was doing. So you see the sine value is this one. Okay, now if I scale it by a factor of 3, because originally its maximum value is 1, now if I multiply it by 3, so you see that its maximum value will become 3. Similarly, its minimum value is -1, so -1 multiplied by 3 is again -3. So I just write 3, and then you understand the operator, that is the static. Now if I run this one, so let's see, you can also run from here, or you can also use the shift and enter. So see, this one is, now you see, you understand that its maximum value is 3 and its minimum value is um, -3. So that's all for today's lecture. You understand we have just used the very basic function which you already have done. So these include the math library, where we can have access to radians. That means we can convert the degrees into radians, and also we have the sine function here. Again, you know that we also have the cos function in the math library, and so many functions are there. So using just these and list, which we did in the previous lecture, we have done this one. Okay, so if you have any question, you can ask in the comment, and let me give you the homework. So homework tasks include write a Python program to plot sine wave with amplitude of +2 and -2. Similarly, write another program to find the find and plot the cos waveform. Okay, so what I suggest that you create a GitHub repository name, for example, Python sinusoidal functions, and upload your Python codes files there, upload screenshot of your output graphs, and share your GitHub repository link in the YouTube comment section of this video. So that's all. One more problem is, can you plot y such that y equals to sine of x plus cos of x? So what you will learn from this homework is the Python programming. You learn the for loop, list, and mathematical plotting. And also, if you do this one, you get improve your GitHub skills and engineering problem solving. Good luck and happy coding. So that's all from my side today. Excellent work, everyone. Today we learned sinusoidal functions and we understand they are periodic with a period of 2 pi radians, or if we talk about in terms of degrees, then we say they are periodic with a degree of 360. Okay. We also use the Python list, we use the for loop and math library, and also for plotting, we use the matplotlib library. Okay, these concepts are extremely important in signals and system. Maybe you come to the engineering, so also in DSP, AI and data science, including electrical engineering, physics, and mathematics. In the next lecture, we'll continue learning practical Python programming with engineering and mathematical applications. If this lecture helped you, please like the video and share with your classmates. So this is the address of the channel. So that's all from my side. Goodbye and have a nice day.